Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 329, I chat with Don Stewart about his family's company, Stewart Filmscreen. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded November 10th, 2016. Episode 329. Stewart Filmscreen at 70. This episode of Home Theater Geeks is brought to you by Drobo, a family of safe, expandable, yet simple-to-use storage arrays. Drobos are designed to protect your important data forever. To learn more, visit drobostore.com and use the code TWIT100 to save $100 off select Drobos. And by CuriosityStream, a subscription streaming service that offers over 1,500 documentaries and nonfiction series from the world's best filmmakers. Get unlimited access starting at just $2.99 a month. And for our audience, the first 2 months are completely free if you sign up at curiositystream.com/twit and use the offer code TWIT. And by Epson's new EcoTank printers. With Epson's line of SuperTank all-in-one printers, you can print thousands of documents without running out of ink. EcoTank is loaded and ready to print when you are. Visit epson.com/ecotank to find out more. Hey there, Scott Wilkinson here, the home theater geek and editor of avsforum.com. This week's guest geek is Don Stewart of Stewart Filmscreen, one of the leading projection screen manufacturers in the world. Hey, Don, welcome to the show.
Thank you so much for having me here. Really appreciate it.
So glad to have you. As you pointed out, last time you were here was about 6 years ago, so it's well past time to have you back, and I'm sure glad we were able to do that. Now, before we get going, I want to make sure that those who are watching the live stream at live.twit.tv can join the chat room from there, or they can go to irc.twit.tv, and you can post questions as we go, and I'll pass along as many as I can. It would help if you put my screen name, which is my name, Scott Wilkinson, no dots or dashes, into the message somewhere. That way it shows up in a different color on my screen, and my eye is more easily drawn to it. So, Don, I want to start with a little bit of history of Stewart Filmscreen. As I understand it, next year is the 70th anniversary of the company. Is that correct?
That's what I've been told. Yes, 70 years.
And
quite frankly, I wasn't around then, so I have to take
You weren't
people's
around
word for
at that point, no. But you are a Stewart, and your family, somebody in your family, started the company 70 years ago. Give us a little bit about that.
That was a few years after World War II, and my grandfather had somewhat of a relationship or was an acquaintance with Walt Disney. And evidently the story goes is that there was conversation between the two, and Walt Disney had these ideas of what he wanted to do as far as theme parks, and at that particular time, no one made big seamless screens to fit what he was looking for. So somehow, between that conversation, the ideas came up and Stewart Filmscreen was born.
So he wasn't looking, was Disney thinking about movies so much, or more about theme parks and
I think
events?
It was more about theme parks and large venue. He also, as far as special effects, using screens for the production of motion pictures. Because at that time, you got to remember, back in the 40s, this is before Disneyland or Epcot Park or anything, and at that time, I mean, Walt Disney obviously was a visionary, but at that particular time, people in the industry thought he was a little bit optimistic, let's say.
Yeah, well, and you could understand why. I mean, as you say, he was a dreamer. He was a visionary. He was looking into the future. where most people weren't really looking. And so Stewart Filmscreen was founded to make screens, projection screens. And you've been in the same location this entire time, haven't you?
Evidently, out of that 70 years, I think we've been here probably in the high 60s, at least where we are now, or we expanded and bought property around the facility and kept building and building and building out. But initially on the land.
Go ahead.
Initially on the land we were on was strawberry fields and 2-lane road out front, and then sporadic oil derricks in the area. Now it's all built up around us. It's all very suburban.
You know, I visited the facility there a couple times, and I found it really amazing that it started from a very small building or house even, and then it sort of expanded out from there. As you say, you bought land around it and built up new stuff. I got one picture that I took while I was there, number 0 in the list that Josh has, which is, I found very interesting. It's almost like a rabbit warren there. I mean, you've got covered walkways and different buildings, and you have to cross the street to get over here. It's really quite the amazing facility.
It almost looks like a back lot on a studio because there's many buildings. It is somewhat of a campus layout. The building you show there is between 2 very large buildings where we spray cast or mold the large seamless screens. That's why you see a lot of pipes and pneumatic compressors and some of the equipment I'm looking at on your screen there. That almost looks like an oil refinery type.
Yeah, I know. And yet Stewart has always been very concerned about environmental impact and so on. We saw a lot of, chemicals being used there. Obviously, you have to make these screens, and we're going to get into how they're made. But I was also impressed by how concerned and conscious the company is about environmental impact. We
do have the Green Guard seal of approval on our products, which means you can put them into elementary schools. Also, the type of business we're in is in a sense heavy manufacturing. And back maybe 10 years ago from the Los Angeles County Board of Supervisors, we were one of 2 companies to win a green award out of how many tens or even hundreds of thousands of companies are in the Los Angeles County. So and the other company was a Fortune 500 company that was picked. So being a small business, we're very, very proud of that fact.
So, as you mentioned, your grandfather, whose name was
Roy C. Stewart, and by the way, I'm sitting in the this is at Stewart headquarters in Torrance. This is the Roy C. Stewart Theater I'm sitting in.
So you guys actually have a screening room there on the facility, which makes total sense. I assume you can put different screens in and out of there, try different things, and
that's correct.
Works.
It's just a small room. This is just a 14-seat theater, and with acoustical treatment. And but we use it for some training also.
Oh yeah, sure. Well, Roy Stewart, your grandfather, when he was talking with Disney, they were really talking about some other applications other than home theater or even commercial cinema to begin with.
Correct.
And I wanted to show some pictures that you sent me here of some of the other applications that really Stewart Filmscreen started with. For example, in studio post-production, after the movie's been made and it's getting assembled and edited and the sound is being added to it and so on, you still need to watch it while you're doing that. And we got some pictures, numbers 1 to 3. Tell us a bit about what we're looking at here.
Okay, that's, I believe, Cary Grant Theater at Sony Studios. Previous to Sony, it was the MGM lot. And that is a very large screen. I think the material on there is ultra matte 130. Obviously, it's perforated. And that particular theater on the lot, they use for dailies or premieres, and also it doubles as a sound mixing room, as you can see the large console there.
And then number 2, I think, is the, I can't remember the name.
Is that Kim Novak, maybe?
Yes, that's the Kim Novak room. Yep.
Yeah, again, looks to be a little bit smaller than the other theater, but I can see the dubbing equipment there.
Still pretty big.
Yeah. Well, these are the larger rooms. There's all the studios that show their dailies have a lot smaller rooms. You'll typically find screens from 16 feet wide all the way up to like Alfred Hitchcock Theater on Paramount, where you'll have a 50-foot wide screen or greater.
Mm-hmm.
Pretty typical.
I think the third one, number 3, is at Warner, New York, and that one is a little smaller.
Yeah, I think that's a dedicated post-production mixing room.
Mm-hmm.
Now, what was it?
Go ahead.
What was interesting in the early 50s is that the story goes from my father is that Kodak was pretty much the primary film stock back then. And what was very important is that the colorimetry, no matter where you were in New York at Rochester or Kodak or Deluxe or Technicolor Labs here in Hollywood or the studios, had to be the same. So if you took a roll of film and put it under your arm and were in New York and came to Los Angeles, you wanted it to look the same no matter where you were. Mm-hmm. So at that time, it was very, very important to have repeatability. And the screen that we still make today, but it had its roots out of that time, is the Snowmat 100 studio screen. Because the colorimetry is exact no matter where you go. So the repeatability of that image is important.
The consistency.
Exactly.
From one screen to another. Yeah, very, very critically important.
Especially in production. So if the studios used the same screen, the labs used the same screen, and the screen was neutral, 100% or as close as you can get to that. We kind of got our foot in the door, and so pretty much the standard screen of the industry to this day is still the Studio Tech 100, Snowmat 100. Those names are interchangeable.
I didn't realize that. Okay.
The Studio Tech 100 is used more so on the residential side. The Snowmat 100 is used more on the commercial side, but it's exactly the same product. Mm-hmm, mm-hmm. It's roots of how we would identify where our product was going is by the name.
Right. One thing I want to mention here is Stewart Filmscreens are often identified by a name like Snowmat or Studio Tech, and then a number. And we've been referring to this number 100, which
means
refers
1.0 game. Yeah.
Yes,
you got 1.0 game.
Right, which means we'll talk about what that means. But one thing it means is you really need a blacked out room to use that kind of a screen, don't you?
Yes, we sell and deliver quite a bit of Studio Tech 100, Snowmat 100 to home cinemas, but it is to normally your videophile type who is projecting or his room is designed as a professional projection room. Big difference. You wouldn't do this in your typical family room with white or light colored walls. The screen is very acceptable to cross reflection. It's a Lambertian diffuser. It will accept ambient light from all angles.
Right.
But if you're a purist and want to see your video as the studio execs do, or how it was produced, then we would recommend the 100. But again, the whole room has to go with it.
Right, exactly. Well, we're going to talk more about that in a minute. I wanted to also show a couple other pictures of some other applications that Stewart Filmscreens have been in. One of them is on-set, what's often called blue screen or green screen. And graphics 4 through 6 will give us some examples of that. Here's one of my favorite movies of all time, Fantastic Voyage. and outside the window, they're inside the ship, and outside is just blue screen, which they're going to overlay whatever they want to on, right?
Correct. Blue screen, I guess the analogy I could use is like multi-track recording, where you 24 tracks or 32 tracks that are each track is dedicated to a particular instrument or sound. Well, blue screen allows you to do the shooting on the sound stage, and where you see the blue in the background, and this I think it was a a submarine in this particular case.
Yes.
Boy, that's
correct.
a young Raquel Welch. Just caught my eye.
I know. One of the reasons it's one of my favorite movies, but that's beside the point.
On the optical printer at a later time, they could put what we call a plate in, and that would be wherever there was blue in the image, they could substitute whatever background at a later time in the lab. So it allowed them to do the shoot, and then the special effects. I think that movie there's a little submarine that was injected inside a human body.
Yep, that's what it was.
In the bloodstream.
Yep.
And so wherever the blue is, they had taken in their special effects department and done supposedly inside the body images of the bloodstream and the veins and the organs, and then they would substitute there later. A blue screen is still used to this day as one of the primaries of doing special effects.
Mm-hmm. And then we also have numbers 5 and 6. Let's take a quick look at those.
Yes,
here's Star Wars. Yeah,
that's a TMAP blue, and that's a rear lit blue, where the lighting is behind the screen. The screen is actually like a big blue filter, and this is using motion control, which will let them do maybe up to 20 different passes of that object. So you can see the camera on the right side. Later, where that the miniature model is, on the finished product, it could be a planet behind it. There could be other vehicles surrounding it and doing flybys. They could composite up to 20, 24 or more different layers, just like multi-track recordings, put layer and layer and layer. So your finished product, it just, it can be spectacular. George Lucas in Star Wars, and then Douglas Trumbull also took these to the max.
Yeah,
really, it blew big. And we made, I think the largest blue screen we've ever made was 90 feet wide by pretty close to 40 foot high, our maximum side. And it was a rear lit blue as this, and it was for Das Boot, which was filmed in Germany.
Oh, no kidding.
They almost had a full-size submarine in front of it on the soundstage.
Wow. Wow. And then finally, number 6, let's take a look at that real quick. Another of my favorite movies, War Games.
Oh, yeah, I think they called that set. That was at Paramount. Like, I was on that set. The Crystal Palace, if I remember right, is what they referred to it. And what was unique there is that room was so big, and that's just part of the set there, that we had to develop a specific screen material for that set. I had to R&D it, and we knew it was coming months and months ahead before they started shooting. Right. And that's a product we called LumaFlex 5050. And what it was is some of the screens, it was a screen that would work both front projection and rear projection. And depending on either side, if they were projecting rear or front, it had to have the same luminance qualities. So some of those images, they didn't have a big enough soundstage to do it all rear projection. So some of those are being front projected, and some of them are being rear projected.
I was going to ask you, which was it? And you're saying it was both on the set at the same time.
Right. I believe the smaller screens, because it takes less space behind them, are the rear projection, and the larger ones up on top are front projection.
Wow. And so you developed a material that could do either one. So it has to have some sort of translucence to it, allowing light to pass through it, but also enough reflectivity for light from the front to reflect forward.
Exactly. And it had to split it literally 50-50 so that the DP or the director of photography could depend on it. Now, just to put the word out there, when you do something that has to do two things at once, it doesn't do either of them well normally. Yeah. But they just brought out the bigger hammer and bigger projectors to project on there, and they made it work. But this is not something we normally would recommend for business use or whatever. Unless you specifically have the equipment to go along with it.
Right. Well, we got a bunch more to talk about. Before we do, though, I'd like to thank one of our sponsors for this episode, which is Drobo. Now, Drobo was started when its founder lost his honeymoon photos to a hard drive crash. How many of us can relate to that, huh? He thought his RAID array had him covered, but his backup drive failed. What? He sought to create a better redundant storage solution, and the Drobo was born. Drobos are designed to protect your important data forever. Drobo invented a new technology, the award-winning Beyond RAID, to solve the limitations traditional RAIDs impose, for example, not being able to expand capacity, having to use the same size drives, and vulnerability to data corruption in power outages. Beyond RAID lets users easily add capacity to a live storage array while mirroring your existing data. To increase capacity, just add a drive or replace a smaller one with a larger one. Drobo also has a battery-backed cache to prevent write failure or data corruption in a power outage. Drobos are also simple to use. You can add or swap drives without the use of any tools, and easy-to-read status lights let you know when you're running out of space. Drobo offers models from 4 to 12 drive bays, providing up to 64 terabytes of protected storage. Drobos connect directly to your Mac or PC using Thunderbolt or USB 3, and they are network-attached Drobos as well. For example, the Drobo 5N and 810N are a network storage system. And what's exciting about them is that their capabilities can be extended with Drobo apps, which are free and installed from the dashboard. Are you upgrading to the new 128 or 256 gig iPhone 7? Do you plan to shoot 4K video on your iPhone 7 Plus? The Drobo Pix app works with your phone to automatically back up your photos and videos in full uncompressed quality whenever you're at home on your home Wi-Fi. Now, I have a Drobo 5N myself, which I'm using as a music server, and starting this week or next, it's going to be filling the house full of Christmas music, holiday music on the Sonos system. Works very well with that system as well. So visit drobostore.com to learn more and to check out their complete line of products. Twit listeners can save $100 off their purchase of select Drobo models, including the Drobo 5N, at drobostore.com by using the discount code TWIT100. That's drobostore.com and use the code TWIT100. And we thank Drobo very much for their support of Home Theater Geeks. So another application that I find very interesting is TV broadcast. And we got a couple pictures to show that as well. You sent me some of CNN, which I didn't put up here, but there's a great one from the Oscars. Now, this is actually a screen that's on stage that is also being broadcast, shown, and broadcast out. So the audience in the hall can see what's on there, and so can the viewing audience at home, right?
Correct. We've been fortunate enough to usually, being a lot of them are here in Hollywood, to do most of the major awards show. Not sure what year this is, but this is an image for being shown previous to the show. I can see the crew's down there and they're doing the setup on the stage.
Right. They're still figuring things out.
Right. So you can. This is generally in most cases, in most for broadcast, it is going to be a rear projection application to isolate the ambient light, and it can be dark, of course, on the backstage too, behind it.
And then I think the next one after that, number 8. Oh, that's the Weather Channel. So
that would be broadcast, and that would be where, again, rear projection, and that looks like what we call 3 projector edge blend, where because you see the wide aspect ratio there.
Super wide aspect ratio.
Yeah. So there'd be 3 projectors behind it, and we have a special rear screens and front screens designed for what we call soft edge blending, which is where you overlap the images 20 to 30%.
That much, really?
Yes. And it's mainly, this is basically from the simulation industry is where we first start seeing the projector blending. And then it takes obviously a processor to be able to do that kind of vista.
Sure. Speaking of simulation, we have a couple pictures of that as well. This is a screen. Well, tell us what we're looking at here.
Okay, we're looking at a let's see, that's Mark Robinson, who's one of our top guys here. That's a torus screen, which is a compound curb. It has 3 different radiuses involved, a bottom radius down by his feet, a much longer radius at the top, and a completely different radius on the side. So it's 3 different radiuses. This would be, again, for edge blending application. You notice that it's a gray matte screen, not white. And so it's designed for multiple projectors and also designed to dampen any cross reflection. Otherwise, if we used a white screen in that application, such as snow matte, and we put up ANSI checkerboards, it would actually cross reflect on itself.
Because the screen is so deeply curved that you would actually get reflections from one end to the other.
Correct. Yes. So, and what's interesting about that screen is completely seamless, and that's our torus design. So what we did is we built the chamber, or a plenum chamber, behind the screen that's completely airtight with our frame around the edge, and then we cut this one would be what we call a windshield cut because it's so curved. It looks like a snow cone paper if you flatten it out.
And that's meant to be part of an airliner simulation where you're looking out a window and you're supposed to see the landscape outside.
This is much bigger than an aircraft one. I'm not sure what this one could be for. It almost looks like a helicopter one to me, but for like a military helicopter. But we sucked the screen back, this flat seamless screen, to get this big compound curve design, and then once it sucks back to its design point, then we have a regulator that holds it there. So the only other way to do that would be able to build a hard shell dome, or to go with this method. So you have 2 ways to do it.
Yeah.
And this is actually, this is small, fairly small compared to some of the large torus screens we built.
Oh man. Furball UK in the chat room is asking, what is the difference between professional screens like the ones we've been talking about and, say, home or classroom screens?
Professional screens, I would say, is, well, one, if we talk about the framing and we talk about the electric roll-up systems and all that, let's just start with that, kind of heavy-duty built. And the optical surfaces, I mean, our customer base, which obviously this is where the story is professional users, and we build for the Disneys, the Paramounts, the Universals, originally the aerospace companies, the Lockheed Martins. So we've always been small volume, high quality, and a lot of one-off products designed specifically for that application. We don't pump them out like for schoolrooms where we have an assembly line and it's popping them out, where you have to build 30,000 screens for the New York Department of Education School Board. So that's just not our makeup, or that's not our DNA. This is basically showing where our DNA is from.
Right. And then that gets expanded into the home cinema market, where, again, you're probably doing more of a mass production thing, but it came out of the work that you did on these one-offs or small run type projects. Right.
All our knowledge, a lot of our knowledge we've learned from our particular customers. Your customer teaches you or asks for things that over the years that were even above our existing bar was. And in order to satisfy the customer, you always have to step up. We're headquartered here in Torrance, California, which is right outside of Los Angeles. And just again, our DNA is the aerospace industry, up until just recently has been headquartered pretty much in Southern California. And the motion picture and entertainment industries have been here in Southern California. So our DNA is we're working with these 2 customers, of course, with the Hollywood people, and you get the creativity, asking you to do all kinds of things that are not even invented yet. You have to figure out how to do them.
Yeah.
And working with the military, the Northrop Grumman's, the Lockheed Martins, and such, they'll ask for something with specifications. And when you ship that product, we normally have to put a certificate of conformancy in there In other words, that we're meeting the specifications that are in the contract or in the purchase order. And believe me, they test them for that. They have the ability and the optical engineers to make sure we're sending them what we say we're going to do, and then it meets the specifications. So we learned the creativity from the Hollywood community. We learned this discipline of repeatability and hitting specifications and putting out honest specifications from the aerospace community. And I guess that would also go along with the last question about professional products.
Yeah, exactly. Also, there's a great photo from Mission Control in Houston, number 10, to see how these giant screens are being used by NASA. Yeah,
that would be originally command and control. That's the original Mission Control, which the Apollo was actually done on, and the Gemini programs from the 60s. This photo is more recent than that because the screens, we updated the room in, I think, 2007, went back and gave it a facelift. You can see the 16 by 9 screen in the center and the 3 by 4 aspect ratios, the 2 on each side. Prior to the redoing that room, the screens were square format, and the center screen was a 10 by 20 or a 2 by 1 format. So we had to go out and reformat them for the new projectors.
Good Sound in the chat room is asking, so a compound curved screen can't be perforated, can it? And if that's true, where do you put the speakers? We're going to talk about acoustically transparent screens in a minute here, but
the only way a compound curved screen can be perforated would be using a hard shell like metal compound curve perforations, and there are some of those out there, and some of the old iMacs use that. But specifically with the using the plenum system and the air evacuation system, as we've shown in the photograph, obviously that can't be perforated. Otherwise, we're depending on that vacuum to hold the shape of the screen.
Yeah.
AMC, American Multi Cinema, we did a big program with them in the 90s where we did probably 700 of their premier rooms 1, room 2 types in their cinemaplexes. Did a perimeter sound system where you have the speakers on the top and bottom and sides.
Oh, but not behind the screen. There wasn't an acoustically transparent screen. Okay. All right. And one last picture I want to show before we move on, which is, specialty venues and theme parks, which is another area here. And here we've got the Disney Circle Surround.
Yeah, I sent you that photo. And that's what you see down at Epcot Park. There's quite a few Circle Visions 360s. But what that photo is significant, if we start talking about gray screens, is that this is where Stewart made its first commercially available gray screens to solve a problem because of the cross reflection problems we'd have with white screens, as you can see by that image.
Big cross reflection problem. Well, we're going to talk about white screens and gray screens here in just a second. But before we do, I'd like to thank another of our sponsors for this episode, which is CuriosityStream. Now, CuriosityStream is the world's first ad-free nonfiction streaming service founded by John Hendricks, the founder of the Discovery Channel, one of my favorite channels on TV. And CuriosityStream is one of my favorite websites for learning all kinds of interesting stuff. They have over 1,500 titles, 600 hours of content, and over 50 hours of 4K content. It's available in 196 countries worldwide, and they're available on many platforms, including web apps, Roku, Android, iOS, Chromecast, Amazon Fire, Amazon Kindle, and Apple TV. There's a wide variety of science and technology content, plus nature, history, and many other topics. And in addition to documentaries, they also have interviews and lectures. Their library includes some really great titles, well, a bunch of really great titles, including, for example, Stephen Hawking's Favorite Places, a brand new exclusive documentary in which Stephen Hawking pilots a fantastical CGI spaceship across the universe, making stops at Saturn and many of his favorite destinations. There's Digits, a groundbreaking 3-part series hosted by Derek Muller, creator of YouTube science channel Veritasium, which explores online safety and security. The series features never-before-seen interviews with former NSA contractor Edward Snowden and co-founder of the internet, Vint Cerf. Then there's Deep Time History, another exclusive 3-part original documentary series that tells the story of the universe's 14 billion year history, including surprising twists to the stories you thought you knew. Also of great interest is Underwater Wonders of the National Parks. In celebration of the National Park Service centennial year, this exclusive 7-part series takes you on a journey below the bodies of water within America's national parks. There are monthly and annual plans available, with annual plans offering notable savings. The plans start at just $2.99 per month, less than a cup of coffee or the cost of one title on competing on-demand platforms. So check out CuriosityStream.com/twit and use the promo code TWIT during sign-up to get unlimited access to the world's top documentaries and nonfiction series completely free for the first 60 days. That's 2 entire months free of one of the largest nonfiction 4K libraries around. Just go to CuriosityStream.com/twit and use the offer code TWIT at sign-up. And we thank CuriosityStream very much for their support of Home Theater Geeks. So I'd love to talk about how you've got all kinds of different screen materials, right? We've talked about SNOMAD and Studio Tech 100, the 50/50 screen, and all these different kinds of screens. What goes into developing these screen materials?
Well, quite a bit. A lot of it's trial and error. We have a R&D. We manufacture 40 by 90 foot seamless screens via some spray cast moldings. We actually mold the screens, and it gives us the ability also to go short runs. In other words, we can produce a 10 by 40 foot screen material that could be unique to itself. So a lot of times we have a customer call and they have a specific need for a material that we currently do not have in our catalog, so to speak. And depending on who the customer is and what their needs are, it's not unusual for us to do R&D and come up with some small samples, maybe just several square feet of it to start with, send them out to the customer or meet with the customer, see if it meets their particular needs. And if so, then we can go ahead and manufacture a large run for it, or larger run for it.
That in fact, pardon me for interrupting, but that goes directly to what Beatmaster in the chat room is asking. Do movie makers or other companies come up with unique ideas or demands on screens?
Oh, yes, quite a bit. For instance, I'm just going back to stories here, but for instance, Disney had their haunted house, and if you go in the haunted house, they would rear project. They look like oil paintings, and they have the big frames around them and portraits of these individuals on it. And as you're in there waiting for things to happen, you would look up and see a young girl, and look up 5 minutes later. Now she's old, and I think one had a cat in her lap or something. You look up a few minutes later, and it's like a skeleton there with the cat as the skeleton. So they were aging slowly, but it was kind of like watching a clock move. You couldn't really see it unless you did that. They needed it to look like oil paintings. So we developed a black rear projection material that had super high contrast, and we built molds using oil canvas and took impressions of it, so that when they were projecting these projection on it looked exactly like a typical oil canvas. So we had to build a mold to do this specifically for that job.
And it had to be a black screen, but a rear projection screen.
Correct. And it had to be, believe it or not, a little bit grainy because the canvas had
it had to look like an oil painting. Yeah.
Yeah, grainy look to it. So it was quite forgiving as far as artifacts in this particular case.
Yeah, right.
Again, different Destiny blue screens for special effects. We discussed war games. We had to develop that particular screen material. Another one was Spider-Man, Universal, down the right in Orlando. They needed a specific type of, there was a 3D ride, and we had a specific type of rear projection 3D that was needed for that particular application. And so we had to go back and develop it just for that particular ride. But there were a lot of big, large rear projection screens on that ride.
Yeah, yeah.
So it's not that unusual.
I wanted to talk a little bit about testing screens, and there was somebody in the chat room earlier. Let me see if I can. Oh yeah, SoCal Ray Jr. Was asking, what do you measure screen gain against? I think he's seasoning the pot here. He really knows the answer to this, but it does kind of bring up graphic 12, which is sort of a diagram of how you test the angle, the amount of light being reflected off at a certain angle, and it also has that little white dot on the screen, which is critically important in the whole testing process. Why don't you tell us about what we're looking at here?
Okay, the little white dot is actually a lab sample. It looks like a woman's makeup mirror. It's about 2.5, 3 inches in diameter. That's magnesium carbonate lab sample, which is a pure white, looks almost like white gypsum. And that's what we calibrate. That's a gain of 1.0. It's as close as we can get to a perfect Lambertian diffuser. So when calibrating all our equipment and our lab equipment, we start with that, putting it in front of the optical bench or in front of the whatever instrument we're using, and calibrate to get the 1.0 gain. And then
so that's the reference. That's the reference.
Exactly. It's the
from
benchmark.
which, yeah, the benchmark. And we should say that you've used the term Lambertian or Lambertian diffuser, and we should make sure everybody understands that that means that the material, whatever it is, screen or this magnesium carbonate, reflects light equally in all directions. There's no preferred direction or a concentration of light in any way. It just reflects things wherever it comes in. It reflects it back out, and it's all very even. That's how you define 1.0 gain, right?
And it also accepts the light from any direction and reflects it back evenly too.
Mm-hmm. Exactly. And then, so here you've got this meter pointed at the screen. You've got this little puck. I've sometimes heard it called like a hockey puck of this white, very specific material. And then you compare, and then you read the light off the screen, and you compare that to what your readings were off of this puck. And you can put the light source and the meter, for that matter, sort of anywhere you want around the screen to see how well or how it reflects light coming in at one angle out at a different angle, right? Well,
the graphics that are up now are how is particularly the lab setup to measure ambient light reflective rejection screens and to see what percentage of ambient light they reflect back to the audience who would be sitting at 0 degrees or exactly in the sweet spot perpendicular. Is this particular graphic.
Right.
For normally
so you've got
doing,
so the light source is off to the side. It's beaming in some light off to the side, and you're looking at how much light is getting reflected back centrally, where presumably the audience would be.
Correct. So you looking down below. Well, let me roll this back just a little. One of the problems is with ambient light rejection screens, and there's many manufacturers of it. Many make statements that it's going to improve your contrast 20 to 1 or 50 to 1 or 10 to 1 or whatever the number happens to be. But there's no juice behind that. And how was that measured? Or did someone just throw those numbers out? So getting back to product development and developing screen materials, you can't improve it until you can measure it. So when we're developing new products or inspecting an existing run of products to make sure it meets our specifications, this is a system we have used internally to measure how much ambient light is returning to the viewer. And you'll see the a voltage regulator on the right, very important part of the equation, because if you have a light source, and the one here you can see at 45 degrees, if you do it at 10 o'clock in the morning and take numbers, and you go back at 3 o'clock in the afternoon when all the air conditionings are running around, that light source will not be consistent. The voltage out of the wall may drop, and we're not getting the same readings that we did at 10 o'clock in the morning. So it's very important to have a voltage regulator to keep your light source consistent, so the output's the same no matter under what circumstances or time you're going to use it.
Okay. You want your measurements to be consistent no matter when they're done.
Correct. And this particular one is, we never, when we're measuring ambient light on an ambient light rejection screen, we never know in the room where the ambient light's going to be coming from. Is it coming from behind the projector? Is it a side window just from the side, very close to the screen on the sides, or the top or the bottom? So for the sake of not knowing where it's going to be coming from, we picked to measure on our test middle ground. Take the ambient light exactly halfway between coming on the side of the screen and from behind the projector, which is 45 degrees. If your ambient light, if we move that ambient light source closer to behind the projector where the spot meter is, the screen's not going to perform as well as far as rejecting light. But then again, if we move it from 45 degrees closer to the screen or more to the side, those numbers are probably going to improve on ambient light rejection than what we have at 45. So we just picked 45 as our particular benchmark because it's the middle ground. We had to put the ambient light somewhere.
Yeah, right. And I mean, this leads us into ambient light rejecting screens, or ALR screens, which, as you say, basically what you want is the light from the projector coming straight at the screen to come straight back at the audience. But stuff on the sides, like where your lamp might be, or the ceiling light, or something like that, or window, comes in from an angle, a steep angle, does not get reflected back to the audience.
That's correct. As a screen maker and designer, pretty much we have a passive device here, the screen. The only way to make it smart is by the angle of incident. In other words, the angle of incident light, we know the projector is pretty much going to be perpendicular to the screen surface.
Right.
And so that's fairly constant. And then the angle of incident or angle of ambient light to reject that is pretty much, and then of course the color of the screen itself.
Well, those are two topics we're going to definitely get into here, including your newest ambient light rejecting screen called Phantom. But before we do, we have a third sponsor to thank for this episode, which I really appreciate, and that is Epson, longstanding sponsor of Home Theater Geeks, and well worth it too, because Epson's revolutionary cartridge-free EcoTank line of printers for home and office introduce a new age in printing. The EcoTank ET4550 wireless all-in-one printer doesn't use ink cartridges. Instead, it features an amazing, innovative, refillable ink tank, earning it the title of CES 2016 Innovation Awards honoree. So there's no more out-of-ink frustration. It includes up to 2 years of ink, equal to about 11,000 black pages or 8,500 color pages, which means you can save up to 80% on ink with low-cost replacement ink bottles. It's powered by Precision Core printing technology. It has an auto two-sided printing feature and a 30-page auto document feeder with easy wireless printing from tablets and smartphones. All EcoTank printers deliver an unbeatable combination of convenience and value. With Epson's EcoTank line of printers, you'll have the freedom to print without running out of ink. In fact, the Epson EcoTank system was named the 2016 Small Biz Windows Printer of the Year. So visit epson.com/ecotank today to transform the way your home, office, or work group prints. For the best combination of ease and value, turn to the Epson EcoTank printers. That's epson.com/EcoTank. And we thank Epson very much for their support of Home Theater Geeks. Epson, exceed your vision. So I'm talking with Don Stewart of Stewart Filmscreen, and we were just about to get into ambient light rejecting screens and the latest such offering from Stewart. In fact, I think it may be your first specifically designed ambient light rejecting screen called the Phantom. Am I right about that?
Yes and no. The first ambient light screen would be Firehawk 1, although we didn't introduce it that way. We introduced it as a back in 2001 when we had a lot of LCD projectors, way to increase black level and gray the shadowing details. It was brought in with that as the mission, but it does a considerably good job, a moderately good job in ambient light situations.
Mm-hmm. But that wasn't its original intent.
That wasn't the mission when it was designed. No.
Right. It was to increase the deepen the black level, lower the black level, and increase contrast with low contrast projectors like LCD projectors of those days. 15 years ago, they've come a long way.
Yeah, and then by the way, you can watch sports with the screen and have the lights up some. That was kind of the way.
Which is another reason to have an ambient light rejecting screen. So that was the Firehawk, but now this year you introduced the Phantom, and we have a graphic of that, number 18. We're going a little out of order here, but I just wanted to show that graphic to let people see kind of what's going on here. So why don't you take us through what we're looking at here?
Okay, what the Phantom brings to the party, so to speak, is number one, it's scalable. It can go any size, up to 40 by 90 feet. Other ALR screen or ambient light rejection screens can't even come close to that. Number two, it's rollable. It can be rolled up to, for instance, we make auditorium size electric roll-up screens, so up to 45 feet wide. And number three, what it brings.
Sorry, before you go on, I was going to say, there are some cases, as you say, of ambient light rejecting screens that cannot be rolled. They have some metallic component to them or something that really prevents them from being rolled up. So that's kind of an interesting feature here.
Well, and some of them are rigid or semi-rigid as far as the body of the screen is concerned.
Yeah.
And then the last is that they can be perforated either with our large cinema perf for very large venues or our micro perf for smaller venues such as home cinema. So it brings those three unique qualities to the party right away. The other is that any screen and ambient light rejection screen is going to bring a little bit of baggage to the party, so to speak. And this one is not perfect. It's not a Snowmat 100 or a studio screen, but the speckle and the solarization is minimal. It's still there if you go looking for it. But we do feel comfortable with it for this type of screen. Yeah.
Now, one of the things in that picture was there was
I kind of missed your graphics.
Let's take a look at that again. You got two layers basically. You got a substrate, a backing there, but then you've got these two layers. Tell us what's going on there.
Okay, first is a flexible screen body, which is cast in our big molding cast. The middle layer is the light reflector, which is a very high reflective optical coating, and the last layer, which becomes the surface of the screen, this is kind of a hybrid between our rear projection screens and our front projection screens, our high-gain front projection screens.
Yeah, it sounds almost like a little bit like that 50-50 material, because the light looks from this diagram, it has to pass through that material to get back to the reflective material and then back out again.
So as it back out, it's acting more like a rear projection screen than it is a front projection screen.
Yeah.
So, I mean, when you look at it, it's fairly simple, or at least looks simple to me. But to make it on and scale it up on this size scalables, the huge sizes like this, it was quite a challenge. But we showed it first at CEDIA in September, and we'll be showing it overseas in February over at the IASC show in Amsterdam.
Mm-hmm.
Hopefully, we should be shipping by then also.
That would be good. And what is the gain of this screen?
Nominally, right now, it's 1.0 gain with a 30 degree half gain. Same half gain as our Firehawk. We kind of find that 30 degree is the sweet spot for an ambient light rejection.
And we should also make sure everybody knows that that's the whole point of an ambient light rejecting screen, is that as light comes in, it gets reflected away. It leads to a narrower angle in which you get a lot of light coming back. And as you get farther and farther away, you increase the angle of incidence. There's not a lot of light coming back to the audience. So that's, and doing that with a 1.0 gain screen, that to me is quite remarkable, because most ambient light rejecting screens are very high gain. The higher the gain, the narrower the angle, generally speaking. And so generally speaking. So some of these screens are, gain of 2, 3, more. And so to have one that's 1.0 is, and yet with a narrow angle like that, is pretty remarkable.
So I think, in fact, you saw the screen when we were showing a 13-foot wide electric roll-up screen at CEDIA.
Yep.
Even though you see the 30 degree half gain, which is one f-stop from being at 0 degrees, so full f-stop of drop. As you walk off axis, I was watching and listening to people who came by the booth, and in this particular setup at the CEDIA booth, you could walk 80, 90 degrees off axis to see it. And people were amazed how bright it was out there. So depending, if you have enough lumens, with any ambient light rejection screen, you got to bring the lumens up higher than you would on a white screen in a dark environment. Myself, I personally like a lot of headroom. But we did one thing that was kind of risky, that some said, but we were showing some black and white material on that screen down at CEDIA. And if there's color shift problems, when you show black and white material, you're going to see it. So we specifically did have a clip of the 10-minute clip we were showing or whatever. We did have like 2 minutes or 3 minutes of black and white. So specifically to show that we were not getting color shift problems.
In fact, when I met you there, when I met up with you there at CEDIA, you mentioned something to me I wanted to make sure we talked about on the show, and we don't have that much time left, so let me get to it, which is the whole idea of static gray. We've been talking about white screens and gray screens. This Phantom, I think, would appear to be a fairly dark gray if you just looked at it without a picture on it. Firehawk is gray, Greyhawk is gray, but Snowmat and Studio Tech are white. But the whole idea that you were telling me about, I would love for you to reiterate here about a screen's sort of inherent black level.
Okay. First of all, let's just start with, there are no black screens, and some people call it that. But so every other than the pure white screens, we have all these different levels of gray screens. Well, from the consumer standpoint, or someone thinking of purchasing a gray screen, gray could be anything from slightly less than white all the way down to almost black. So all these shades of gray. So the static gray level is the color that the screen is if you put it as you would see it in the room without a projection image on it. So in other words, just as some, let's start with Firehawk, because it's our most well-known gray screen product. The G4, it's exactly 50% gray and 50% white. It's like 4.9, and you can see that on the chart there. And this gray wedge up there, it's there for illustration. It's not 100% accurate because it's just a gray wedge made off my computer. The gray hawk, which is a much lighter gray material, by itself is about 7.2. The phantom screen in a static gray level is quite a bit further to the left of Firehawk. So it is going to be about 3.8 or 4.0, depending on which run. It will vary a little from run to run. The closer it is to black, the better ambient light rejection it's going to have, because obviously the ambient light lights up the screen, and the darker the static gray is, the blacker the blacks are going to appear. Remember, black is completely passive. Projectors do not project black, so the screen itself is going to determine what that particular black level is.
So then the question is, why not make a black screen?
Because then you're trying to balance reflectivity. If it was pure black, I projected on matte black walls before, pure black, just to see what happens. And if I make a small enough image with a bright enough projector and make it, let's say, a 2 foot wide image or so, it looks pretty darn good. But in the real world, the key of it is to have it, like, for instance, just use the Phantom as an example, a 1.0 gain, but the black level, static black, is down at below 4. That's where you're doing the balancing app, having enough reflected light to get enough white light back and the colors, and also have the black level on the passive gray do his job too. It's a
balancing act, as you say. Yeah.
Oh, and not to get color shift in your means of doing it.
In the process, yeah. There's another graphic too that has a kind of a split screen effect. I believe that is probably 17. There it is.
Yeah, and this happens not to be a Phantom. That's a Firehawk, and I actually snapped that with just a pocket handheld little camera. But to give you an idea of static, the static gray on the left is our Stewart Snowmat, the studio screen. On the right is the Firehawk, which is on that one to tail scale. The static gray there is 5. So what happens there is that the particular image of the Tower Bridge, it looks like, at night, is that wherever it's nighttime, the projector's not even on; it's turned off because it's supposed to be black there. So even though my meter, I can't measure this, but the way we see pictures, obviously the image on the right, I can tell it's a nighttime shot. The image on the left is completely washed out. So on the static gray level, the Snowmat on the left side is pure white. It's like the magnesium carbonate lab sample. It's a 10. It's a 5 pretty much there on the right. If you look at the above the bridge, and just look over to the right of that, of the black frame around it, and that's pretty close to 0 as you're going to get. So you're seeing the static gray on white, gray, and black there. Just as an example. Yeah.
Let's see. I think I've got another question or two in the chat room. Beatmaster is asking, under what circumstances, say room, size, distance, does a curved screen make sense?
Well,
that's a different topic than we were on there, but
no, and boy, there's a lot of opinions on curved screens. I personally like not a very deeply curved screen, but I don't mind a shallow curved screen, especially if you want to sit a little bit closer, especially when you're looking at scope. But from a technical
standpoint, which means super wide angle.
Yeah,
movie.
Yeah, but this becomes personal preference. You walk into the Academy Theater of Motion Pictures Art and Sciences up in Hollywood, the Samuel Golden Theater, you're going to find a curved screen. You walk into the Cinematography or Director of Photography Guild up in Hollywood, guess what you're going to find in their auditorium? A curved screen. So using I like to sit fairly close to the screen, so I like the idea of the curve, but I see a competitor, and I'm not going to say who it is, selling curved screens, slightly curved with matte white screens. We're saying you could do, because as soon as you curve that screen, like we discussed a little bit earlier, that matte white screens is putting out light equally in all directions. So it is washing itself out when you put an ANSI checkboard across it. The white's reflecting out and washing out your black squares. So if you're going to use a curved screen or slightly curved screen, it needs to have some gain and some directionality to the screen material you put on there. So you're not putting the output.
Right.
Going back to the question.
The curved screen, I've always maintained that curved screens make sense if they're large enough with respect to where you are. I've never been a big fan of curved TVs, for example, because they're just not big enough to make sense. Would you agree?
Yes. Oh, well, you probably remember the first projection systems that had a parabolic curved screen.
Yes, I remember that. What were they called? The Nova Beam or something?
Yeah, but they kind of looked,
It almost like a part of a sphere. It almost looked like a segment, a square segment cut out of a sphere. I mean, it was a compound curved screen.
Right. But back then, the screen gain was silver aluminum material, and it was a gain of like 12. And because the projector was maybe 50 or 60 lumens, and the screen had to work harder than the projector did. Yeah. So that's the only way they could control the hot spot, was by doing the compound curve in both directions and actually bringing the hot spot out beyond the edges of the screen. So
right. So the whole screen was in the hot spot, right? Exactly.
You made the whole screen the hot spot. But,
by the way, just for those who don't know that term, hot spot, as you increase the gain of a screen, you run the risk anyway of more and more of having what's called hot spotting, which is the center of the image is brighter than the sides of the image. And you want to avoid that as much as possible. You want the whole image across the whole screen to be of uniform brightness.
Right. It kind of looks like a vignette, so to speak.
Emily the Strange is asking, do you own patents on this stuff, or can anyone use this technology? I'm sure Stewart Filmscreen owns patents on a lot of what it does.
Yes, we do have intellectual properties. Some of our older, we invented the tab guide screens on the roller screens. My dad and my dad and my uncle were both sailors. It was sailing boats, and I like to race them and things. And that kind of came off of the idea of how we were setting up sails on a sailboat. But the original tab guys.
I didn't know that. But when you look at a Stewart screen that rolls down out of a motorized mount on the ceiling or whatever, it does have sort of lines, strings, sort of attached and making the screen, giving the screen tension, making sure it's flat. And it does kind of resemble the lines on a sailboat. It's fascinating. I never knew that before.
But it was good enough back then, and I think I was in the 70s or something, and no one said, let's take out intellectual properties on that. Now, if you look at the high end of most of screen companies, a lot of them have that available as a tab guide option. So certain things are patented, and certain things that should have been patented, when you look back on it, were not.
And now other people are using it?
Correct. But probably by this time anyway, and some of the stuff, it would have been eminent domain by now anyway. Oh, well.
One last thing. We're a little actually beyond time, but I really wanted to get this in here, and that is acoustically transparent screens. We talked about microperf and perforation before, and this allows you to put speakers actually behind the screen. And I got a couple of great graphics to show on that. Starting with number 13 now this is a picture. Oh man, we're talking some moire pattern there. Let's see. Oh, better in the actual stream. Okay. So tell us what we're looking at here.
Okay, you're looking at the bottom is our standard, what we call cinema perf for large venues. This is typically what you would see in a large studio screen up in the studios in their viewing rooms, or
and in commercial
movie
cinemas.
Theater. Yeah, and it's specifically designed for high frequency. Instead of dome tweeters, you'd want to be using the high frequency horns, which you typically get in a commercial type environment. The horns at like 16, 20 inches wide. Mm-hmm. Above it is the micro perf, which was developed along with NHK and THX in the early, probably 91 or so. And that is 10.2% of it is porous. And so almost 90% of it is actually screen material. So when we punch it out on our machines here, 10% of the screen ends out on the floor. The whole diameter is about 24 thousandths of an inch, and versus the, I think our cinema perf is in the 40-odd thousandths, and it's about 8%, the one below porous holes.
And I'm amazed. Correct. I'm amazed that you can put a speaker behind a screen that's been perforated by tiny little holes and still get good sound through it. I mean, that's amazing to me.
Well, when you think of 10% of it is going through, I mean, generally, if you're going to be putting audio, you're serious, you're going to be putting any audio behind any screen, I think you want to get the room calibrated. Generally, with perforated screens, we can even replace a old perforated screen up at the studios that's 20 years old. And we bring a new perforated screen in, even though it's the same hole pattern, they're going to automatically recalibrate that room normally, because the difference of the new screen is going to be a little bit softer as the other screen is cured out over the years and may be a little bit more brittle. So it will sound, there could be, not to my ears, I don't have the golden ears, but someone has the golden ears, there may be some sound difference. But I notice every time they rescreen the rooms, they recalibrate the sound.
Recalibrate them. And it's amazing how transparent they are. Pictures 14 and 15 will show us an example of that from a home theater that I profiled on AVS Forum. So here it is with it sort of normal, looks like a normal kind of screen. But this guy put lights behind the screen. And you can actually, when the lights are on behind the screen, you can look through the screen and see the speakers. It's amazing.
Right, right. And if you turn the lights down on the front side of the room, you wouldn't even know there was a screen there if it was black. So, yeah, I like that photo. That's a very cool photo.
Yeah.
Nice audio stuff back there, too.
Yeah, beautiful really nice. Really nice.
Yeah.
One last question, and that is, you've recently, I think Stewart recently has been doing perforations for a long time, but recently you introduced a woven material, and that's the other way to do acoustically transparent screens, where you can put speakers behind the screen. What do you think of the relative strengths and weaknesses of perforation versus woven?
Well, the one that we have, and actually we sell more of it in the European market than we do in the U.S. market, it's called Harmony. And it's made by a third party, just like everybody else is. We don't, most everything at Stewart, we make in-house, make it ourselves from raw materials.
But not this woven material?
No. It's a third party. The one thing I found, and I haven't gotten the answer to this, but when we do the test of the woven material with the microperf, woven sounds pretty good when you use the woven by itself. But most people put an additional black cloth behind the woven to give it higher contrast. When you put the speakers behind the black woven, then the screen surface, now you're going through two surfaces. And then the numbers don't look as good as what I see published. I would say the main advantage to the MicroPerf screen is that we have dozens of options as far as the optical for the video on the front side. In other words, since we have our own perforation machines, all the different screens that Stewart make on the front projection side, we can perforate any of them. So I'm of the school that all screen materials that we make is application driven. The right screen in this room is the wrong screen in the next room. That's why we make so many different types of surfaces and so many different choices for those applications. With the woven screen, you're pretty much down to one screen surface, which is usually in the area of about 0.8, maybe 0.9 gain on white wovens. But you got to live with that. And I'd rather go the other way, where we have different optical surfaces to choose from, and go with a MicroPerf. But
yeah, so more flexibility, in other words.
Exactly.
Mm-hmm. But the one thing I've heard about perforated screens that one needs to think about is that it's often best if you can put the speakers a little farther behind the screen, not right up against the screen with perforation. And you might need to actually apply a little equalization in order to make the sound be what you want, which is less of an issue with woven screens. At least that's what I've been told.
Okay, I agree with that. Well, with the perforated screens, again, we were talking about calibrating. You should be doing equalization. But again, with what we have here and the testing we have here, when we did the double black fabric with the woven fabric, it wasn't perfect either.
Yeah, indeed. Well, listen, we've run over our time, but I so appreciate you being here and hanging out and talking about screens. And I want to thank you so much for all the work that Stewart has done. You have done with that company, your family's company, and congratulations on 70 years in business.
Thank you, Scott. Again, really appreciate the opportunity to be on your show.
Yeah, thank you. That's Don Stewart at Stewart Filmscreen, and you can, of course, read a lot more about what they do at stewartfilmscreen.com. You can always find me at avsforum.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott and at avsforum. You can always find previous episodes of Home Theater Geeks right here at twit.tv/htg. And on our YouTube channel, youtube.com/twit-home-theater-geeks. Next week, my guest geeks are scheduled to be Theo Kalamarakis, a renowned home theater designer, and John Bishop, who's known as the personal cinema architect. They've been having an interesting discussion that I asked them to bring on to the show, and so they will be talking about their thoughts on what's important in home theater. So I do hope you will join me for that. Until then, geek out.